Good day and welcome back to Everything Mathematics. And today, Monday, we're going to continue the series that we started actually last week, Monday, on matrices. And today, it taught us to do the determinant of a matrix. On Friday's video, we would have looked at how to form the adjoint. Today, we're looking at the determinant. And tomorrow, God willing, we're going to be putting both the concepts that we did today and Friday in order to write up the inverse and see the implications or the importance of being able to do that. So our objective for today will be a rather straightforward one again. You'll just be able to learn, or we will learn today, how to calculate the determinant of a matrix. And that's our objective for the day. So first of all, how do we go about calculating the determinant of a matrix? Very simple. And here is just the description. Then we're going to look at the practicality of it, or the actual calculation. So to calculate the determinant of a matrix, we simply have to find the difference of the product of the leading diagonal from the minor diagonal. And that, again, as always, might sound complicated, but let's just look at a reference. So here we have an example. Look at matrix W. Oh, by the way, if you look at this W here, this is the symbol for determinant, and that's a modular sign. So oftentimes, if you want to find the determinant of a matrix, you would see, for example, if you have matrix A, you would see these two lines standing by. That's the determinant. And of course, very rarely, you would also see DET. You might see these two. So these are just two connotations that you should be aware of, two notions. So DETA, or you would see A with a modular sign. These two are saying the same thing, determinant, right? That's just by the way. Good. So again, back to what we said on our notes here. To calculate the determinant of a matrix, we find the difference of the product of the leading diagonal from the minor diagonal. So we have to remember, as we did on Friday, the leading diagonal, or as we say sometimes, the major diagonal is AD here, and the minor diagonal would be CB. So the determinant would be the product of the leading diagonal, which is A times D, and then you're finding the difference. So you have to subtract that from the product of the minor diagonal. So it's AD, and of course, if AD was a number, it's A times D, and then whatever you get there, you subtract from C times B. And that is as simple as that, you get your determinant. So the next example here, we have one with numbers, and this is how we go about doing it. So look at matrix F. For matrix F, we have 2, 3, 1, 4. That's matrix F there. And to find the determinant of matrix F, again, the leading diagonal, which is 2 times 4, remember the product of the leading diagonal, and you're taking away that from the product of the minor diagonal. So if we look at this example here, the leading diagonal or the major diagonal is 2 times 4. So 2 times 4, that will give us 8, and you subtract that from 3 times 1, which will give us 3. So we're supposed to end up with something like this, and ultimately leaving us with the determinant of 5. So the determinant of matrix F is 5. And that's really all there is to it. So let me do some more examples. So I have 2 here that I will do for an example, and then I have 3 for you to attempt on your own. So for here now, this will be equal to, we're asked to find the determinant. So S with the modulus will be equal to minus 3 times 5 minus, then we have 8 times 6. No, my bad. 8 times 2. And once we work out that here, we will see that you'll get minus 15 minus 16. So at the ending of the day, the determinant is negative 31. So the determinant for matrix S is negative 31. It's minus 50 minus 16. And that's it. That's it. Let's find the determinant for matrix T. So that will be T, and we have that in a modular sign, and that will be equal to, in this case, we will have 4 times 8, and that will be subtracted from 6 times 2. The product of the leading diagonal minus the product of the minor diagonal, or the product of the major diagonal minus the product of the minor diagonal. 8 fours, that would give us 32. sorry there, minus 6 2's, that should give us 12. So the determinant of this matrix T here would be 20. 20, 20. So yep, this is it here, this is it here. Of course, you could always pause this video here and go through it again slowly and make sure that you get it. And here you have 3 examples for you to do. And as usual, of course, here is where you take the opportunity to pause the video and give it an attempt. But I will not pause, I will move on, and let's see if we get the same thing. So we find the determinant. So let me see if I could find some spaces here. So let me try this one here. So we have R, the modulus of R. So let's call this number 1. The modulus of R will be equal to the leading diagonal, the product of the leading diagonal, so that's 7 times 2, minus the product of the minor diagonal, which is 3 times 9. Here we will have 14 minus 3 9s are 27, I believe. Good. So the determinant for this one will be negative 13. 14 minus 27, that's negative 13. As the rule goes, you take away the smaller one from the bigger one, but you keep the sign of the bigger number in terms of face value and not place value, right? So that will be negative 13. Sorry about that again. Number 2, we want to find the determinant of z. So we have z, and that's equal to leading diagonal, so that's minus 2 times minus 4. And then taking away from that the minor diagonal, so that's 4 times 8. If I do the maths here now, negative 2 times 4, that will be just 8, and you're taking away 32 from that. Minus 32. 4 times 8 is 32. And of course, when we do the maths here, you're supposed to get negative 24 as your determinant. So this is a determinant for R, this is a determinant for which one? For Z. And let's see if we could squeeze in L up here. So that's number 3. The determinant of L will be equal to the leading diagonal, the product of the leading diagonal, which is 6 times 4, minus the product of the minor diagonal, which in this case is 5 times 5. Good. And when we work on this here, we'll get 24 here, minus 25. 5 5s are 25. Good. So in this case here, the determinant is negative 1. Good. And it's very important that we be able to calculate the determinant. Of course, for CSEC, what I notice, you oftentimes are asked to find the inverse, and when you're finding the inverse, of course, you need to know the determinant. But oftentimes, you will also have to only find the determinant of a 2 by 2 matrix, which is all well and fine. In fact, that's the easiest one. But however, at higher levels, you will have to realize that 2 by 2 matrix is not the only type of matrix that you have to be able to find the determinant of. In fact, you have the 3 by 3 and you have the 4 by 4 matrices and many other types. And even there, you would learn that there are other methods in which you have to find the determinant. One of the very common ones, and I like it a lot, but I always forget the name. But it's a very intricate method in which you have to get a whole set of zeros and ones. I honestly can't remember the name right now off the bat. And another thing that you should know now, and again, this might be very far-fetched for the average CSEC math student, but one thing that you need to note, and you will learn this maybe more so tomorrow, it will make more sense. But whenever you get a determinant of 0, you should note, or you would realize, that the inverse of that matrix do not exist, or it will not exist. And I wouldn't dwell too much on that, but maybe I will try to remember to incorporate it in tomorrow's video so that you would know. And that is a very, very important concept also when you're learning abstract algebra, because you would understand that if a matrix has a determinant of 0, then it cannot even make a group, and that will be significant. So for now, I don't think CSEC put that to the test as much, but note that if you have a determinant of 0, then the matrix will have no inverse. And in abstract algebra, that simply means that that matrix or that group, or that, what should I say, the number of elements that you're considering cannot form a group. But let's call it a day for today. And again, as usual, feel free to like, subscribe if you haven't as yet, and turn on that notification bell so that you'll get videos daily as they come out from Mondays to Fridays. Until then, you take care, and I trust the lesson was simple enough.